Hi everybody. I'm sorry for the clickbait title, but you're here, so it somehow worked. Do I hate cookie cutters? Not really. You can find many nice cookie cutters online, and most of them are fine. But my experience is that when it comes to real projects, real applications, they are a little bit less fine, so to say. People tend to copy stuff from here and there, and the result, not every combination is always the way to go. My name is Miloslav Pojman, I'm from Prague, and I work here for Pure Storage, which is a really beautiful office in the city. This isn't supposed to be kind of top 20 tools for your productivity talk. Today, I want to really focus on the core structure of Python projects. Because when it comes to Python, everybody has a slightly different taste. And sometimes my only concerns about that taste could be some kind of inconsistencies between projects. But sometimes I see some kind of anti-patterns that repeat again and again. So I think that we could start with a few examples of what can go wrong. What do you think is wrong in this kind of simplified project structure? It's simplified. Exactly. That's the problem. You should not have under init files in the source directory. Because this file marks something as a package, as a module, something meant to be imported. But which means that it allows you to write something like import source server. But source isn't a package. You don't import source, you import from source. Your code lives there. Because source would be a terrible name for your code. So I'm glad that there were not everybody knew this. The correct is obviously import source, and you can make it clear by deleting and yielding the dunder init files. Here is another example. Do you see anything wrong here? Yeah, it's true that you cannot run something with you cannot import something with with dash in its name. But you can still run it, which could be fine in some cases, but not here. And the issue why I'm showing this is that the problem that I see is that the script is nested inside the package. You see under init.py file. And when Python runs a script, it adds its parent directory to sys.path. That means that you can write something like import models. But this import is not a relative import. Python sees this as a different import than myapp.models. This means that with this kind of setup, you can end up with 2 copies of one module in memory. And I have seen people trying to figure out for days why some exception isn't being called. And the reason was that the exception was duplicated, as everything. And all of this was only possible because somebody ran some script from inside a package. The third example is a little bit more nuanced. And my main problem here is that I don't know how I'm supposed to use this. Is app a package, something that should be imported, or is it more like a source folder, so I will import from inside of that? Now, depending on the answer to that question, depending on the intended usage, I could add some recommendations. If the intended usage is import app.htp, then I would add the dunder init.py file, because it's not strictly needed, but it would really clarify the situation. It would make clear that it's a package. And I would probably rename it something more less generic, like my app, or something for your project only. If the intended usage is import HTTP, then I would rename source to app. I would rename app to source, because that's the standard name that everybody is using. And also, in this case, we could end up with different problem, and that would be that our http.py will conflict with the built-in Python HTTP module. And here is a bonus question. What's wrong here? Yeah, it's Django, which is not wrong. I love Django. I learned Python thanks to Django, and this is like source code for Django project website. But I don't really understand why this framework is pushing me into having everything in the top-level namespace. Why I need something in the root directory for everything? How am I supposed to avoid conflicts with built-in libraries, with third-party packages? How do I even know from what all of this are packages and what is just, I don't know, documentation? And I don't want much from my project layout. Essentially, this talk will be about how to achieve two goals. One goal is that I want one-to-one mapping between Python files and modules, which means that I won't end up with two versions of one module in memory. And this also means that I don't want naming conflicts with other stuff. And my second goal is that I want something that is easy to run and test. And by easy in this context, I just mean that it should be something normal, something that we all are used to. So I would like to talk about real basics. How can I run Python code? The obvious approach is obviously to type Python and name of some Python file. For this talk, it's important to remember that this will add the directory with the file to sys.path. Thanks to that, we can have a bunch of files in one directory, run one of them, and all others can be imported. If I don't know where my program lives, but I know that it's importable, I can use python-m, a name of the module. This is handy. For example, if I run python-m http.server, I will get a server running, and I don't really care where the HTTP module is on disk and some kind of side packages or whatever it is. And finally, the most convenient way how to run something is just name of the program. No Python, no -m, just the tool that I want to run. And this is possible when it's coming from some installed package. That's how we usually run all our favorite tools like pytest, mypy, raf, pip, essentially everything. But before I can run something, I have to get it somehow, place it to my file system. And what options do I have? The simplest approach is just to copy it somewhere. Sure, it's not exactly enterprise-grade solution, but this is why people choose Python. You get a bunch of scripts, put it somewhere, and they run. Or I can use something like pip. When something is published on pypy, this is definitely the way to go. That's how we install essentially all public libraries today. But pip and other package managers can install not only libraries, they can also install applications. So this could be useful for us. Think of mypy, raf. You don't import them, you run them, but you still install them using pip or other package manager. And now the crucial part, why this theoretical introduction? Only some combinations work. When I place a script into the current working directory, I can run it easily, but I won't get any command to run. For that, I have to install the package. But when I install the package, I don't really want to call it by its file name, because the file name will be ugly and somewhere that I don't even know where it is. Python-m works with almost everything. That's why I would recommend this approach for scripts and automation, CI, all this stuff. But it's not really something that I would like to type every day. So the table tells us that there are two sweet spots, kind of developer-friendly configurations. But they are very different. So I think it's important to pick one and be intentional about it, to know what I'm doing and why I'm doing. Because from my experience, problems usually come when we land somehow in the middle. I will call one approach simple and the other one packaged. The simple approach is essentially when you run your scripts. For development, you clone code from Git, install any dependencies, and run a script. You don't install your own code. It just lives in your working directory. Production deployment can be quite similar. Just copy or upload your files somewhere, install dependencies, run it. There is no packaging, no installation step. And then we have packaged applications. This essentially means that we treat our application as they were libraries. For local development, we install them in editable mode. This has an advantage that a package can define its own dependencies, so we don't need an extra step to install the dependencies. And then we run it, and we can run it using some global alias that pip will create for us. And for production deployment, we can also delegate most of our work to pip. It doesn't matter whether you're deploying to Docker or building Debian packages, you essentially let the package manager to do all the work for you. I'm using pip in my examples because I believe that it's visible from these examples what's actually happening under the hood. We will look at other package managers in a second, but it's good to realize that the underlying principles remain the same. You either install the package or not. So, how do other package managers work with our two approaches? I will start with Poetry. Poetry creates a packaged application by default. You can see that all code is hidden in the source directory, so you won't be able to import it unless you install the package. And there is no script to be run directly. In pyproject.toml, there is a build system defined. This is an important detail, because when I have this in my project.toml, I'm saying that my code should be built and installed. It doesn't make sense to copy something manually when I have the build, when I have build system for that. You can tell Poetry to use flat layout without the source directory, but there is no command line option to get an application that is not packaged. To get a simple application without packaging, you have to edit pyproject.toml manually. Delete the build system section and set some package modes to false. So my interpretation is that Poetry has an escape hatch if you don't want to package your application, but it's not something that I would use with Poetry for new applications. And then we have the new superstar UE. UE creates a simple application by default. Note that everything is in one directory, so you can easily run main.py and you will get the root directory to syspath, So if you add more modules, more packages, they will become importable. But it's also really easy to create package application with UV. Just pass -- package to UV init. So it seems that UV maintainers are equally prepared to support both approaches. Maybe they have chosen the simpler one just because it's more, I don't know, novice friendly, but they seem equal to me. In PyProject.toml, there is build system defined if and only if you use the packaged option. And I like how UV does not need some extra option like poetry for saying that the application is packaged or not, because it can just check it's build system, yeah, it's packaged. There is no build system, it's not packaged, easy. So, which approach is better or more popular? I tried to figure out it a little bit, so I reviewed public Cookiecutter templates, base project, essentially everything I have found online. Out of those packages that I saw, 28 templates use the simple layout or something like that. Only 10 of them were packaged. But I believe that the difference is mainly historical. I was also checking some quite old templates, and they are coming from times where the Python packaging wasn't so standardized, and we had the tooling that we have today. If we look at GitHub stars, the numbers will be approximately equal. But in this case, it's worth noting that majority of the stars for the package category is coming from one template only, fast API, full stack, something. So essentially it's simple package or fast API. So this comparison doesn't really make sense. So I guess that we should just accept the fact that there is not one right way to do it. But I still believe that we can simplify it into those two approaches, two recommended layouts. I have the simple approach. With the simple approach, I place an executable script to the project root. It's important not to place this script into a package or some directory because I want the project root access path and nothing else. But it doesn't mean that I cannot use packages. I want to use packages because I want unique names for my application. Namespace. I believe that most of application code for one application should be in one package with a unique name. And the main.py can be really simple, just import some function and run it. Tests live at the same level as the application in the test module. pytest has a nice functionality that in its default configuration, it looks for the first directory up without the under init py file and considers it to be sources root and adds it to sys.path. So with this layout, you can run your tests without additional setup and you will be able to import your application from the tests. The key points are, there is no source directory because imports would no longer work out of the box. We have under init in the application module and in the test module. And to run the application, we have an entry point at the top level, a script executable, essentially. I call this approach simple, but I don't think that it would be inferior. It's just like what Python was always. But if you find yourself somehow re-implementing parts of pip, maybe it's time to package your application properly. Packages can have the code hidden in the source directory. And there was lots of written about advantages of the source layout, and I don't really want to go into this rabbit hole today. But still, I would like to add two arguments which are specific to applications. The first one is that applications tend to have much more stuff than libraries. You know, various configuration and Docker files, Docker Compose files, Helm templates, Jinja templates, JavaScript files, React framework, all this garbage. So I like when my Python code has a nice home in the source directory, isolated from all that other ugly world. And my other argument is that when something is not immediately visible, when it's a little bit hidden in the source directory, people will be less tempted to run it directly. And we want to nudge them to install the package, essentially to read README and use it as we intended. You can add under main file to the application to support Python-m and be essentially good citizen. When it comes to tests, my recommendation is slightly different that you will find in most templates, I believe. We have the tests directory, but I didn't put the dunder init file there. Instead, there is a test package. One reason for this is that I like the symmetry between source and tests, but that's not the main one. The main one is that if we use the same structure as with the simple layout, pytest would put the project root to sys.path. And we could run into exactly those issues that we saw at the beginning. It would be possible to get import source working, it would be possible to get duplicate imports. I mean, this is just nicer from my point of view. And in the test directory, I have a test package. And this test package provides unique namespace, unique name for all my tests, for our test files. According to pytest docs, under some circumstances, you can have duplicate test file names, and it works, but this just avoids lots of problems. For example, mypy doesn't like if you have two file names, if you have duplicate top-level modules or file names. In pyproject.toml, we define a build backend and an entry point for our application. With this, our package manager should take care of the rest. When I look at this structure, I would say that it's pretty boring. I'm wondering why I'm even talking about it. But for some reason, most real applications I see do not look like this. When I heard about app/app at yesterday's keynote from Django about Fast API, I felt like, thank you, it's not only me, it's happening to others too. So, I mean, if you don't like the structure, maybe just the simple approach is for you. There is nothing about my structure or so on. But I would be really careful with taking just some parts of it. I don't know. I like source folder because, I don't know, some influencer wrote that source folders are good. But do not package it. That's probably not the way I would choose. So the bottom line is, do you have a few scripts in a directory? Sure, no problem. Don't overthink it. Complex applications can benefit from proper packaging. And I have shown you a pretty standard structure how a package application could look like. And I don't say that this should be a cookie cutter that you should be using, because real projects will need much more. They will need much more decisions to be made, tools to choose, toys you like, and that's where your creativity, where your insights will be valuable, and where your cookie cutter should start. And if this creativity, if this cookie cutter is based on something like this, I will be very honored. Thank you for your attention.
Thank you, Miloslav, for that session. So we now have 5 minutes for questions. The first question.
Hi, so in the spirit of gratefulness, I want to say, first of all, thank you for this. I believe that foundations are very important. And if I may recommend, if you really want to go for Cookiecutter, use Copier instead, and make sure to update your templates. That's just recommendations.
Yeah, that's a good point. But there are, some kind of old-fashioned people who mention Cookiecutter because they just want some shiny title for a talk and don't know exactly that Copier exists. So yeah, essentially, I learned that Copier is much better. Just I wanted some name that everybody understands.
Thanks for the great presentation. I wanted to ask about approach you showed regarding the tests. So you are placing them in the separate tests directory. Will then this approach work also correct if I will write tests right next to, for example, CLI.py, which is in src directory / my app, and here I have CLI.py, and if I will put test_CLI.py, will it work?
You mean something like Django approach, when you have like test module directly in the application?
Probably yes. I have no idea about Django.
Essentially, you have tests and application at one place.
Yeah.
And it's if you have this setup, I mean, there can be arguments for this, and essentially it's much easier to use it everything. It often means that you distribute your tests, which might be a good thing or not bad thing. But what's definitely good about this approach is that it works out of the box. Because if you install your application, you install with the tests, so the tests are there and you can run them, and you don't have all the problems that I was trying to solve by, I don't know, introducing the package and test directory and configuration and mypy stuff. It's like part of your application. So then you have no problem.
Okay, thanks.
Could you explain again how you end up with the same module in memory twice?
It's because maybe a story lesson, but in Python 2, if you do this import models, it would be relative import. And I believe that not everybody realized that it's something changed since that. And people just write what they are used to. And or even found that, for example, some IDEs just do some code completion and fire there some import, and like then don't really understand what's happening there. So you will end up one module which does import models, and in another place you will do import myapp models. And the Python import system essentially works in a way that it looks, have I imported the module with this name already? If yes, just return it. If no, import it. And if I imported models and now somebody is asking for myapp models, it's a different name, so I haven't imported it, I have to import it. And normally, one of those imports would fail because it would be wrong. But if you have two directories at Python path that are nested into each other, then you can use both names because they will just use from the different source root. Essentially, whenever, for example, when I'm configuring PyCharm, I put there like, what is my source directory? And you can choose many of them because like life happens. But what I never want is that I have two of them nested into each other, because it means that there are two roots to resolve relative to, and you never know which one will be taken, and you will get with duplicate names.
The last question.
Thank you for your talk. I wanted to ask about your simple layout, as you said. So I was wondering, if you already have a PyProject.toml, can you make the case for why you would want to have the main.py still separate and not as an entry point? Because that's 2 lines in the PyProject.toml, and then users can just install it.
If you look at like the UE thing, yeah, this one, it creates PyProject.toml without, I'm clicking animations. This one, Not. UV? Ah, wait.
But what UV does is just a single module package.
It's just one way how I look at this is that, like, I like to use Git for everything. I have some, I don't know, helper that I write, and I don't really want to spend some time with Cookiecutters, UV, whatever, just write some file. And you end up with files, and at some point, maybe it's good to add PyProject with dependencies for it, or README, or, you know, adding. And that's how, at some point, you realize, okay, it's really complicated, just package it. But I don't need to do the complex stuff from the beginning. And essentially, like, yeah, that's it. Like, and with PyProject, it's true, you have PyProject, but it doesn't have build system defined. It's there just to, I don't know, configure what your favorite tools and give the project some name. And because this is generated by UV, I think it's perfectly supported. There is like nothing wrong about it.
Okay.
With poetry, I thought a little bit, yeah, it's working, but it's not how it was meant to be used.
Okay. Thank you.
Thank you, Miloslav. That's the end of our session. Those who have more questions, please feel free to post on the Discord channel, or you can approach the speaker personally. Thank you.